Hello, my name is Rohan Kamath, and my topic for the short story assignment is dimensionality reduction. So, as every day, a very large and huge amount of data is generated, the main problem is visualizing this data. So, if you have x and y variables, then visualization is easy. But suppose the data is n dimensional, so you cannot visualize this data. Also, even though the high number of dimensions provide more information, this can be a curse. So these are the problems with high dimension data. First is they require high time and space complexity. Second is if we have too much information, the model can overfit. And thirdly, not all features may be relevant to certain problems. For example, if we want to predict the height of an individual, then a feature of the person, such as number of property he owns, is not relevant, right? So we can eliminate it. Now, this is a broad classification of the techniques. First is by only keeping the most relevant variables from the original data set. So this is called as feature selection. And second is by finding a smaller set of variables, each being a combination of the input variables containing basically the same information as the input variables. And this technique is called as dimensionality reduction. So now I'll talk about the dimensional reduction techniques. Now first is missing value ratio. Now suppose you have been given a data which has a very large number of missing values. Now, the option with you is you can simply drop those missing values. But what if the number of missing values are considerably large and dropping them will simply eliminate a huge amount of data? So it will be a data loss. So what you can do is you can simply set a threshold like 50%. So any dimension having uh, missing values above the threshold, you can simply eliminate that. Now, second is low variance. So, consider a data set wherein all the observations have the same value, say 1 maybe. So, if we use this variable, do you think the model can improve? The answer is no, because the variable will have zero variance. So, what we can do is we can simply calculate the variance of each variable we are given, then drop the variables which are having low variance as compared to other variables in the dataset. So by doing so, it will not affect the target variable because the variables that we are dropping or the dimensions we are dropping have a very low variance. Now, third option is correlation, high correlation filter. Now, high correlation filter is basically checking the correlation between two variables. So it means that if two variables have high correlation, then they have certain trend. Now, for some models like linear and logistic regressions, uh, if there are certain dimensions which have high correlation, this will bring down the model performance. So we can simply drop one of the variables or one of the dimensions. Third is an ensemble method which is called as random forest. So basically, random forest generates lots and lots amount of decision trees randomly. So this is basically providing a hierarchy or a relation between the dimensions of the data. And using this random forest, you can simply identify the more important dimensions to be considered. Now there is one more technique which I felt was very important. I'm not actually done it, but it's called as factor analysis. So suppose we have two variables such as income and education, and these variables have high correlation, as the people with the higher education level have significantly higher income, and vice versa. So in this technique, what we do is we group the variables with higher correlation. So each group is called as a factor, and these factors are small in number as compared to the original dimension of the data. However, these factors are difficult to observe. And the last technique is basically principal component analysis. So this is a widely used technique. So PCA is a technique which helps us extract a new set of variables from an existing large set of variables. So now there are several points that I would like to go through. First is principal component is a linear combination of original variables. Principal components are extracted in such a way that principal component explains a minimum variance in the dataset. Secondly, principal components tries to explain the remaining variance in the dataset and is uncorrelated to the first principal component. And third, the principal component tries to explain the variance which is not explained by the first two principal components, and this goes on. So now I'll talk about how I actually implemented dimensionality reduction in my computer. So my job was basically analyzing the Airbnb dataset. Now the Airbnb dataset had something called as host and superhost. So I had to classify given certain amount of data whether a given for a host is a host or a normal host or a superhost. Now the data set had a large number of dimensions. So dimensionality reduction was very important because there were because it was important to understand which dimensions are actually relevant for this particular analysis. So I plotted a heat map. I found out all the superhost and the host, and then with this the least. So I used a visual technique wherein the least correlated attributes I only considered those. So I can see these are the attributes, and finally I made some more visualizations, and then I came to a conclusion that these attributes are important. Then I computed everything, used this for classification, and later on I realized that only these attributes which are there on the screen are actually important for classifying given a particular host details whether it becomes a superhost or a host. So this was the actual implementation of dimensionality reduction. Thank you.